the first guest is Jason. Jason, thanks so much. You were the first believer. You said yes. Helped me figure out everything, logistics, operations for this event. Jason bootstrapped a space company called Made in Space almost 10 years ago, and or more than that, probably 12 years ago, right? 14 years ago. It's been a while. And we're going to talk more about Made in Space. It got acquired eventually. And then now he's started another company, Outpost Space, manufacturing space. They have his VC funding. So he's seen both sides. He's bootstrapped a company through sales, and he's also raised venture funding. And I think it's really interesting. So please help me in welcoming Jason. Here. Please. So, Jason, you bootstrapped a space company. What does that even mean? I thought hardware was very expensive. Tell us more.
Okay, so why don't we just maybe pass that off because it doesn't work. Okay, so my last company was called Made in Space. We started that in 2010, and I've always had this philosophy: if you can just go to the customer first and get money from the customer, there's no reason to take dilutive capital. So, the idea of Made in Space was take space manufacturing out of science fiction and make it a reality. And this is 2010. MakerBot just came out with their first 3D printer. It was made of balsa wood. You had to put it together yourself. And we had this idea of putting a 3D printer on the space station. And when there's one space station and technically one customer, you're just going to go to that customer and talk to them and see if they want to, work on this with you. So, and this is an interesting point. Like if any of you are thinking about or working on a space company and you want to work with NASA, there's a good chance NASA already thought of this idea, probably in like the 1980s or so. And there's a person at NASA back then who studied the idea, maybe did in our case, a parabolic research flight with a wax 3D printer in the 90s. And then they write a really nice report and it sits on the shelf because it wasn't commercially ready. So the trick there is find that person and go befriend them. So we flew out to Huntsville. We met with that researcher. We said, we're going to put the 3D printer on the space station that in the 1990s you wrote about. And then we just formed a really good relationship with that group. And then we did that together. And that's literally how we bootstrapped Made in Space. And then, and it became a very successful company. We got the first and the second 3D printer on the space station, a machine that recycled plastic waste into filament for the 3D printer. We manufactured optical fiber on the space station that was extremely low loss. We did some metallic 3D printing, and then got to the point where we had a $100+ million contract to build a spacecraft that would build its own solar array once it got on orbit. And then right around then, the company got acquired, and then I went off to start Outpost.
So, I know we chatted earlier a bit, and you mentioned what the first year looked like. Oh, okay. Okay. I got distracted. But you talked about what that first year looked like, where you were in a full-time job, you're working days there, and then at night you were off to the office and working nights and weekends. Just talk to us a little bit more about, that first year where how were all of you supporting yourselves, paying the salaries? What was the first contract, right?
What I've learned having Outpost is venture-backed. Made in Space was not. I've learned there's definitely pros and cons for both. And with Made in Space, we did the first year we were able to get NASA to give us a contract to do zero gravity flights, no money exchange, just flights, and we just put in our own money, got sponsors to give us things for free. Pete Warden, the center director of NASA Ames, gave us a basement under a wind tunnel to operate out of, where it was so dirty we'd have to sweep the floors every day to get the dust out from the night before. So it was a lot of beg and borrow, and so the first year, no revenues. The second, that led us to getting a SBIR contract, which was a phase one, 125K contract. That we got that the second year, and that was all the money we made that year. We made, you know, it's like the story of Hanukkah. You have like a little bit of money that somehow lasts way longer than it should. And we did that because we were the founders, we were all 25. I took another job at another space company next door. We had a few employees. Everybody, the salary, I think the biggest salary was probably 50,000. You know, nobody was taking big salaries. And, but that made us survive. And then by the end of that year, probably about 9 months in, we were able to get NASA to give us a mission contract to build and fly the first 3D printer. So there was a lot of like working right up to the very last week of cash before the next thing took off. But I think like that was a special time. Like I couldn't do that anymore. Like, you know, with a family, be able to go sleep under the desk every night. But what I learned from that was like one of the most fun times I've ever had in my career was like literally going to this one job and then like 2 times a day checking in on the company and then staying there all night and then going back to the job that paid me. And that was for the first year. And then when we got the mission contract, I was able to just be full-time made in space. And what I do now at Outpost is I just try to make sure that we create a work environment that works for everybody. If you're, you know, younger or, you know, looking to put in tons of hours because you're super excited, you should be able to do that. If you have, you know, a family to go home to, you should be able to do that. But I'll never forget like the value of that time, how important it was.
No, so you also brought up the difference between venture-backed and bootstrapping your company through your customers. Can you speak a little bit more about that and what the learnings have been? And you also mentioned in our conversation previously that you encourage bootstrapping early days.
I mean, Outpost is, even though we're venture backed, we're still very much bootstrapping the company. We have, we've raised I think arguably a pretty small amount of capital. We did like a seed round in 2022. I wrote the first check and then my co-founder from Made in Space, Aaron, wrote the second check. So we kind of kicked it off, raised a seed round in 22, 7.1 million. And then we've raised a little bit of money like on safe since then. But in that, like the focus was just go right to the customer and get contracts. So we have like, with that seed round, we built and flew 2 satellites to orbit, which was really like the brain of our Earth return vehicle. So we put 2 satellites on orbit. They're up there right now with customer payloads on board. And then we just went and got, you know, mainly DoD as our customer and NASA. And like this summer alone, we won 40 million in mission contracts, which is really exciting. It's an incredibly big challenge we just got ourselves signed up for. So the 40 million in contracts is funding us to do 4 Earth return missions in the next 4 years. And to say like a little bit about Outpost, where our goal is to build multi-ton Earth return. It's a huge lesson I learned at Made in Space, which was I always thought that the hardest problem Made in Space would have to solve was making a 3D printer work in 0 gravity. Like I know like most of you are engineers here, like you're probably imagining like all the complexities of how do you do that. And while that was like technically a hard problem to solve, the hardest problem was actually a logistics one of getting anything back. These were like the first parts ever manufactured off Earth, and we needed to get them home to study them. And it was really difficult to get anything back. And then when we made the optical fiber on the space station, once again, took forever to get it home. The 3D printer itself, the Air and Space Museum had a spot for it, and it took 6 years for that to come back home and go to the Air and Space Museum. And you know, you can imagine my mother, I keep telling her son's going to have a hardware at this Air and Space Museum, and it's not coming back. So I learned the hard way that space is a one-way street. We have a lot of ways to get things into space and very few ways to get things back. And that's really a challenge at the large scale, like the multi-ton scale. And everything I've ever done has always been built on like a bet on the future that I feel is a worthwhile bet to make. And the bet I'm making is that Earth will have a return lane and that there'll be just as many things coming from space to Earth as we today have going from Earth into space. And maybe more so, like there might be a point in time where it completely shifts and we see more things coming from space back down than the other way. So to do that, we needed to build a multi-ton Earth return. So that's really been Outpost's focus, and that's what these missions we're building right now are tied towards.
So can you break that down? What does building a multi-ton Earth return look like, and what's like the next 3-year vision? I know you mentioned you're planning the first launch in 2 years, and then what's the sort of 7-year, 15-year? What's the long-term vision, and how do you do that?
Well, the Earth return is not the only, like that alone isn't the answer. Like you actually have to have accurate and precise Earth return. It doesn't help if it just lands anywhere on Earth or crashes anywhere in the ocean. You need like landing pad accuracy. And I worked on Space Shuttle, and one of my favorite things about it was right next to the shuttle landing facility is a building that processes the payloads called the Space Life Sciences Lab. So it's like you land and the thing that you're bringing back is inside the laboratory within minutes. So you need that if you're doing Earth return. So we started off with just kind of a blank slate. How do you make space vehicles land accurately without sacrificing all of the payload? Historically, you get one or the other. You have high payload budget. So we wanted large payload. This is hilarious.
I know.
Large payload, or we wanted large payload and landing pad precision. So a completely different idea. We have our vehicle is much more of a satellite than some sort of like Earth return capsule. It has a heat shield that deploys open. It's made out of a high performance carbon fiber textile. It pops itself open like an umbrella, gets us into the atmosphere, and then actually from a very high altitude, about
we'll just do like
So we're converting our aircraft.
I think so, yes. Awesome. This is how startups work.
Yeah, so it's. I mean, we can play a video, or you could find the videos online. We're coming in with this very large shield that allows us to come in very slow. So we're very low ballistic coefficient. We slow down subsonic in the upper atmosphere at 65,000 feet. We open a paraglider wing. That's like U-2 spy plane altitude. We move up there, and then we essentially convert our spacecraft into an aircraft that altitude, then it autonomously flies itself around the space. We literally have 10 mics.
Yeah, the mics don't work.
This one works now. All right, it's fine. I'll just hold both. All right. I mean, do I need to repeat all that, or did you guys get that? Okay.
So, what is the government? The government is your primary customer right now, right? What are they paying you for? $40 million. What are those contracts currently for?
Yeah.
If you can talk about any of it.
Yes. So like, when you have a vehicle that can return large quantities of payload with very high accuracy, it's useful for us on the commercial side to do things like space manufactured products that you need to build at scale and bring back to Earth.
So we'll pause there, and Bruey's coming. I'll ask him later as well.
Yeah.
For anyone who doesn't know space manufacturing or hasn't looked into it, why do we need to manufacture in space in the first place, and what does that market even look like?
Okay.
What kind of products?
I'll answer it I think we'll give a really good perspective from Varda, and then I'll come back to the government answer that you asked me. Okay, so here's my take on this after doing this my whole career is, historically, what we've always seen in industry is that new processes unlock entirely new industries, right? The advent of the coke oven in 16th century England allowed England to make steel at a very low cost, and that steel allowed England to go away from burning birchwood forest and instead burn coal. That's how the Industrial Revolution started, was literally one new process unlocking not just one industry, but all of industry. And that story gets repeated over and over and over again. The interesting thing with space is that there are aspects of the space environment that allow us to create entirely new processes in manufacturing and material processing. You have not just zero gravity, what we think of, you have variable gravity. You can create any gravity you want without any G vector. So imagine centrifugal casting without a Earth vector. You have a radiation environment to dump heat. You have this interesting temperature environment. And it there's all these very creative new things you can do with that. And none of these are new ideas. Like when the space shuttle was getting designed in the 70s, NASA wrote hundreds of reports of all the great things you could manufacture in space when you had low-cost launch, which the space shuttle was supposed to do. So all the companies today are doing is just taking the things off the shelf from the 70s and 80s and just making it real, because now we finally do have low-cost launch. That's all it is. So I'll let, Will can correct that or add to it. For us, because we're focused, we're very future focused on how do you build incredibly large scale Earth return, like something that takes up a whole Starship launch and can loiter in space or get delivered anywhere you want. That allows us to, go do some interesting things in space for the commercial side. But because that vehicle has such high accuracy landing, it's really great for point-to-point logistics. So the contracts we're winning from the military is to look at how do you move things around the world quickly and land them precisely in very hard to reach locations, contested regions where we have it would be very dangerous to put humans. And that's kind of what motivates us from the national security perspective, is that it looks like, I think on the surface, it looks like Outpost is like a last mile delivery solution, but we really see ourselves as a life-saving organization, because if you today look at the military supply chain, you're putting our military personnel in harm's way to put things in important places, to rescue somebody who needs to get rescued. And with this solution, we can put those things there completely autonomously from space. So yeah, we're really excited to demonstrate that.
You're building a capsule as well?
No, it doesn't look like a capsule at all. It has it's what we call a low ballistic decelerator. So the heat shield pops open. Imagine a small espresso cup on a saucer. Our spacecraft is the espresso cup, and the heat shield's that big saucer. So what that does is there's no backside. The complete vehicle is exposed on reentry, but the large diameter heat shield is protecting us from the reentry environment.
Okay, well, we're going to figure out our journey to space and back, and I'm so excited that Outpost is helping us get to that future, and this is what this evening is about. We'll do Q&A right at the end with all speakers at 3:30. But with that, Jason, thank you so much. I know you're hanging out for a bit, right?
Of course.
Everyone can chat with you. Everybody, Jason. I'll see you back at 3:30. All right. Okay, so next up, we have John Coogan from Founders Fund, who will be interviewing Doug Bernauer, who is the founder of Radionuclear. Right.
Is this thing on? And where do we want it? I go here? Okay.
And apologies for the sound setup.
Good.
No worries. They finished all the testing for us.
Is this too loud? Are we right here? Where are we doing? Okay, we're good. Cool. Well, thanks for having me, and thanks for being here, Doug. Thanks for hosting us. I wanted to start with just kind of like a high-level overview of what you're building. Give me the latest milestone. Give me a preview of like the next milestone.
Yeah, what we're building. So you guys are all here at Radiant, so it's not just me, but the whole team behind you that continue to work while we're having our event here, which is great. But we just finished this, what we call the passive cooling test for our reactor. And what we're building is a 1 megawatt nuclear reactor that's portable. You can build in a factory. It has the power conversion system along with the reactor and shielding in a box. So you can take it anywhere, set it down, operate it. You have 5 years of clean power. It's a megawatt, so it's enough power for like 1,000 homes. Then you can shut it down, and then we take it back to the factory, refuel it. And so it's really the nuclear power people want. It's immediate, delivered very fast to you. You just use it. You don't have to do anything special, and it's just sent back, and someone else deals with the nuclear waste. So this demonstration was about getting 12 tons of steel and precision machine graphite up to temperature, and then showing that we don't need any power. We don't need the grid to just to make it safe. So normally a big reactor, you need coolant pumps running, but we don't need that because it's 1,000 times smaller and is high temperature capable. So that was proof of safety. And that next big milestone is really only 18 months from now, fueling the full-scale system at Idaho National Lab.
Okay, so 1 megawatt. Is that the smallest nuclear reactor? Can you take me up the ladder from what you're building all the way to Chernobyl and like what I know?
Yeah, it's very, there's many orders of magnitude.
Okay.
So it's really useful. So normal grid scale reactor is about 1,000 megawatts. They have reactors up to 1,600 megawatts. That's the kind of biggest in the world, but you can kind of group them all and go, they're about 1,000 megawatts today. That's enough power for like 1 million homes. So
that's what people think of when they think of Chernobyl.
That's
Fukushima.
Yeah, 92 reactors in the U.S. are operating. Okay. Yeah, and those are all of that scale. Yep. And so you need millions of homes. You need a grid, right, to distribute that amount of power. Those take a decade to build or so. It's a giant hole in the ground, and you're welding all the buildings together on the site. Has the big cooling towers you would picture. And there's a bunch of companies working on a smaller system. They call it SMRs, small modular reactors. It's a bad name, but what they mean is it's like 100 megawatts or so, about 10 times smaller. And the idea is you can build it faster. That like the amount of welding and stuff that you need to do on site is much less. And so maybe you can deploy in a couple of years only instead of a decade. Then there's a 10 megawatt kind of size range where we would call those microreactors instead of SMR. And a microreactor, you might be able to not need the grid to cool it, for example. That only becomes possible if you can reduce the amount of fuel you have so that it doesn't become a big challenge to cool the system. We're working on something even smaller than that. So we're working on a single megawatt electric. Single megawatt electric is like a diesel generator alternative. And it's enough power for about 1,000 homes still. So it's still quite a bit of power. Might be enough power for like one really, really large business also. I think, here we don't use anything near that.
Do you have a buzzword for it yet? I mean, we went from just big, huge reactors, Chernobyl, then there's, small modular, then there's micro, and then there's what you're building.
Portable micro.
Portable micro.
That's what let's call it, portable micro reactor.
Okay, there we go.
I don't know. Maybe we'll get something better if we'll figure something out. Maybe you can help me.
Yeah. We need to workshop some stuff. If anyone has any ideas, bring it up in the Q&A. Nano.
You can go even smaller, but like at every smaller size, the reactor costs more. You can't make electricity as cost effectively, and that's why the big reactors are really big.
I mean, you just said you can always go smaller, but backstage you were telling me that I can't have one of these in my car, and I was promised an atom punk future. I played Fallout. I want a nuclear powered car. Which one is it?
We can make you like a 10-ton car.
Okay,
right? 10-ton car. Worse than any other car. But it could be technically
with lots of shielding, or is this something that's only an option once I fully upload to the cloud and become an Android?
A robot version of you could.
I need to be a robot.
That's technically also possible.
It's the tissue is the problem here. Okay, so it's on me. It's not on the nuclear industry.
That's right. That makes sense. Well, and reactors get even smaller than a megawatt. So if you go to a space reactor, there are things that have been launched that are on the order of just a few kilowatts.
Yeah. Well, what about those reactors that are operating in like research labs and universities? I feel like those get really small sometimes because people walk around these campuses and they don't really freak out that they're like on a nuclear campus. Or
they
whatever.
do sometimes get smaller, but oftentimes they're even bigger. So like MIT's reactor is 100 megawatts.
Oh, wow.
Was put in the 1950s, uses high enriched uranium, technically a weapons grade material. It's right in the middle of the city.
Yeah.
No one even knows. There's like, well, don't know and you think it's fine.
That's amazing. Yeah, I love it. Okay, so there's been a ton of news, literally just the last few weeks, about hyperscaler big tech companies really driving a transformation in the traditional large-scale nuclear reactor. There was a talk about restarting 3 Mile Island, I believe. There were a few other candidates, Microsoft, OpenAI, a lot of the AI training firms that are looking at how are we going to build a gigawatt scale data center for a massive large language model training run? They're looking to nuclear. What has been your take on that? And what could kind of the peace dividends of that be to other companies and operators in the nuclear space?
That's a lengthy question, John.
Sorry.
I think it's really good that people are looking at nuclear again. And I think the public are open enough to going, hey, we have this possibility of making more power in a really clean manner, and we actually care about that quite a bit more. We have a lot of wind and solar power, which in the 1990s we had like no wind, and even in like the year 2000 we had almost no solar. And so those are really, we have a significant amount of those power sources now. The nuclear designs of the past are limited to really make baseload power, but there's no reason you can't design them to work with wind and solar. It was an important part of the grid in the past. So I think it'll be really cool because we can have a new generation of nuclear developed, and all these tech companies have the money to afford committing to being customers for these companies. So I think it's going to have a big effect and drive there being more startups. But I do think it'll be focused more on the SMRs, the 100 megawatt sort of size range and up.
Yeah. I mean, especially if you're trying to throw together a data center like very quickly. Like, I don't know if you've been following what XAI has been doing, where they basically like threw the kitchen sink at the power generation because they're one of the few companies that doesn't have like really strict ESG targets. So they can burn coal if they want. They can bring everything from the grid. They can just do everything. And so like, if you're trying to spin up a huge large language model training run in just a few days, like you're going to want a ton of those reactors. You're going to want everything you can possibly get, right?
Yeah, absolutely. I mean, the niche for portable microreactors is really you want immediate power, or you go talk to your utility and they're like, we'll tell you in 2 years when you could have more power. You go, I can't wait. So you just need it immediately. So it'll always be, it'll help fuel every size range, including ours.
Yeah. What about kind of like public-private partnership between the government? Like clearly, there's a lot of people in this room that do great work on Capitol Hill, but Microsoft probably has a little bit more resources. They probably have a massive office in DC. And if they're pushing a nuclear agenda, and then Google's also pushing a nuclear agenda, and then Elon and XAI are doing this, and it's like every single powerful person in tech is now aligned around nuclear. It becomes like a bigger issue than just like, right now, no offense, like you guys are kind of like this niche little pocket of tech. But if it becomes like the overall narrative of tech, it'd be very good for you, right?
Absolutely. Absolutely. And I mean, we have not made as much electric power generation in the country in a long time. And so I think this is really the root of the problem, and why these really big companies who have a lot of funding, they want to build more facilities. They want to have more data, more algorithms, more compute.
Yep.
And they're going to tap the grid, and they're like, it's not there. So they're basically funding making the grid more directly.
Yeah.
But it's absolutely helpful to have everybody aligned to going, yes, nuclear power.
Yeah.
To make that helpful for us at our small scale, we sort of need a regulatory overhaul.
Sure.
Is one of the problems.
What does that look like?
Well, I don't want to go way down into it,
Sure.
but the way that you regulate something that's 1,000 times bigger than something else, that should be a different method. We don't have that right now. We have like the same thing applies to all sizes, which is a pretty unreasonable thing. If you think about like for aircraft, that'd be like having a 300 person aircraft and like a 0.3 person aircraft, right? Regulated the same way. Doesn't make sense.
What does 0.3 of a person look like?
It's like nope,
small.
right? It's like remote control thing.
Yeah, I guess like a DJI drone or something. Or...
It's still FAA regulated, but
but
in
very
a different
different
way.
Very different, especially with like the what is it like 180 grams for drones or something. If you get down really small, it's like you can basically fly them anywhere.
Yeah.
So kind of on the AI question, there's this thing that's been kicking around my head, which is that we've seen this. Obviously, there's like a massive run up in like any company that throws AI anywhere near their name or business model, and their stocks are way up and they're raising tons of money. Then you have the kind of the true beneficiary of the AI bubble, which is like NVIDIA, and like all the value accruals there. And I think that NVIDIA is now responsible for more than 110% of the profits of the entire AI industry because everyone else is losing money and they're making money hand over fist and have great margins. But I think there's a lot of people that are kind of asking the question of like, what comes next after, all the chips get purchased by NVIDIA? Like, it should be energy. Energy should be the bottleneck, especially as you listen to Sam and Elon talk about, okay, we need to get to a gigawatt data center and then a 10 gig. Why do you think that the overall market hasn't really adopted that position yet? Like, why is this still like a cocktail position in that it's something that a lot of smart people are like talking about, but the market doesn't seem to be reacting to this yet?
Yeah, it's because there's no new nuclear design in the U.S. in 50 years. The last one's in 1970, which was at Idaho National Lab, and that was the 52nd reactor they had developed there. So they did it pretty quickly, and they did quite a lot of reactor design in the past. But they're paper right now. So that's really the limiting factor. Is like there are a bunch of deals too you'll hear announced. We can get excited about them, but often the deal doesn't have a committed date. Doesn't have like firm payments. And if you look at the history of nuclear in the U.S., you will see these like cycles of every about 10 years us putting some money out there, and usually it's a public-private partnership in some way. But you'll see the delivery dates just move further and further out until the potential would-be customer of that reactor goes, I can't do it anymore. Like the costs keep going up and the schedule keeps going out, and I didn't sign up for that.
Yeah, it does seem like there's like we're kind of bottlenecked on both sides. Whether it's like obviously ESG stuff on the oil and gas stuff, which is good, I think, in many ways. And then on the flip side, it's like overregulated on the nuclear side. That's really tough. And then solar, cool, but I want to be able to train my AI model at night, and that's tough.
Yeah.
How are you thinking about the long-term balance between solar and nuclear on Earth and beyond, or just in general over the next like 10, 20 years?
Well, solar is just really far away. Nuclear fusion, right? Starting point.
Yeah.
Everything's nuclear. There's no other way to make power.
Yep.
E equals MC squared. Sure. You want to convert some matter, you get some energy. It's the only way it works.
Sure.
Even geothermal is radioactive decay heat.
There you go.
Just noting that. But I think solar power is great. You should absolutely put up a solar panel and catch some of that solar power from the sun. Like, thanks for running the sun, right? We should be thankful for that, and we should use that energy. And when it's the daytime and right there, it's not facing the wrong way, we can get all that power. And nuclear should just be filling in at night and when you have clouds, and it lets you have power exactly when you want it, not when it happens to be available.
Yeah.
But perfect way to do this would be, you have a couple megawatt solar field, and you can leave a little cutout in the center and put microreactors in there.
I like the version of the future where we just say yes to everything, and it's like underground nuclear reactor with a bunch of solar panels on top, and then there's windmills on top of that, and we're just collecting all of the energy from that like 1 kilometer like space. Just maximum.
The nuclear reactor doesn't need to be underground, but
if it is, then you can put solar panels on top.
Yeah,
you don't want to put it on top of the
4 megawatts in 4,000 square feet. Like it just doesn't matter. Okay. You can just have a little keep out.
So aren't we going to run out of fuel at some point?
I think it's like 5.5 million tons of proven uranium reserves is the today number globally. Yeah, it's the heaviest naturally occurring element on Earth, but it's really abundant.
Okay.
There haven't been enough half-lives of the material for it to have gone away from whenever the Earth was made, right?
Yeah, but
what do we think? 4.3
What if we go through like a kind of Kardashev scaling scenario where we're increasing the amount of energy consumed by humanity by an order of magnitude every 2.5 years, and we do that for 1,000 years? Like at a certain point, we must run out. So is this stuff where does this stuff come from? Is it renewable whatsoever?
Yeah, it's I love this one. It's made all the time in the cosmos, right? When you have a binary star system, which is really, really common, and those stars die, and they happen to be the right size, they will not become a black hole or a red giant. Or brown giant, I guess. They will become a neutron star. So there'll be a nova event. They will shed a bunch of charged particles, and you'll be left with just neutrons. If you have two neutron stars, they will eventually be drawn together, and they will trigger a massive supernova event on collision with one another, or just accruing enough mass from the lighter mass partner. And in that event, you have the conditions to create new uranium. That's where it all comes from. And then it gets scattered throughout the universe. And I think the age of the universe is like this 13 billion years. Earth's only like 4 billion years old. And so some star died, and that's what we're sitting on top of here. Sure. And it happens to have uranium. So we know it's some mixture that included some of these neutron star merger events.
Cool.
And there's an excess of neutrons in the atom that make it stable. Right, its half-life is very long. It's hundreds of millions of years for uranium, and we can go and take that and put it in a reactor and control it and make perfectly clean power. And we should do that with every single bit of it that's under our feet, and we should do it before it runs out. We certainly shouldn't be around for 1,000 years and still be stuck on Earth.
Yeah.
And we just go like get some more uranium that's out in those other places.
Yeah, so like in the ultimate long-term future, like millions of years, we could see like Dyson spheres mining the active stars, and then also kind of uranium hunters traveling around the galaxy finding new uranium.
I mean, yeah, maybe you should be thinking about a Dyson sphere around a binary neutron star system.
Capture, yeah.
That is, go directly to the uranium source.
I love it. Yeah, that's the future.
I don't know if that's at all practical. Somebody can figure it out.
Someone's going to raise money for it. And
let us know.
Cool. Well, I mean, that's about as abstract as we can get. Let's bring it back to today. I'm sure there's a lot of people here that are interested in deep tech and hard tech and whatever the buzzword of the day is. Like, do you have advice for people who want to get into the industry, have an impact, grow their business, just kind of anything that you've learned, lessons, or like, do you just want them to come work at Radiant?
Of course, come work at Radiant. That's step one. I don't know. What are my lessons learned? Like, if you're gonna start something, make really sure that it's a great idea, that it holds up to your own test. Right? Test yourself. Question all your expectations. Make sure like there's an actual customer, that customer is ready to buy on the schedule that you're attempting to make something. I never intended to found a company. Like, I was at SpaceX for 12 years, and I loved that. I got build the first rocket with legs for Elon and did these other cool projects, but I left because I saw this big gap in nuclear technology. And from the work that I did on Mars, I know that you have to have megawatts of nuclear power to do fuel production on that other world, and that's actually, I think, the critical thing that makes life multiplanetary. So I left to come make the company that would then be able to make those reactors on that time scale. As far as advice goes, like, I don't know, I follow my passions. I think work on the most challenging thing with the biggest impact. That's just the greatest, the most satisfying for me. And that's what makes me just, I get up every morning and like go like fight the good fight. Like, I get excited when I get thrown roadblocks because I go, if we unlock this, it won't matter. Like, this is the noise, right?
Yeah. Somewhat related. Have you done a work back? So there's this Mars transfer window that only happens every like 2.5 years, right? Have you done a work back from like which one you want to be ready for?
No, I'm definitely not targeting that today.
You should go in the pitch deck.
I wrote software with the help of other people at SpaceX that did pick exact launch dates and deploy a power system and make fuel for return missions so that you could have a Starship stay there, make enough fuel that you land another one, and send another one back so that you have one there and back every one of those cycles.
That's awesome.
That'd be a cool contract to get for those reactors.
Yeah.
You just send another one each time, send a bunch of construction vehicles as well.
But there's still a ton of work to do out here on Earth.
Yeah, absolutely.
Cool.
Well, the job is make a nuclear technology company, mass produce nuclear reactors, then we mass produce space reactors.
Yeah. Sounds like a good plan to me. Thanks for talking with us.
All right. Thank you.
Thank you. So much. Thank you.
Quick announcement. There's someone who lost his passport. Okay. Richard Macy? No? Okay. Nobody wants the passport. Great. Okay. Next up, we have Well, first of all, let's give it up for John and Doug. That was a great talk. Okay, next up we have Bill Bruey. He's building Varda Space right down the street, 10 minutes away. Let's welcome him on stage. Will, join us. Thanks for being here.
Thanks for having me.
Thanks for the great tour this morning.
Oh
my God.
Yeah, absolutely.
Yeah.
Thanks for swinging by. Yeah, he got to touch something that was in space today. So I touch it every day on the way in, just as a reminder.
And
The
can't
capsule
wait to be in at the next launch in January. I'm so excited. But it's been a long journey, and you figure out new things every 2-3 months. And I know we were talking about some things. So tell us about why space. I asked Jason this too. Why manufacturing in space makes sense for anyone like who's not thought about it ever, right?
Yeah.
What?
Yeah. So the way I think about it is changing gravity during the manufacturing process. So if you think of gravity as a fundamental force of physics and it's static at 1 for all of us during every manufacturing process, it'd be really cool if you could change that constant during the manufacturing process, and that opens up the envelope of what you can manufacture. It doesn't mean that everything you're going to manufacture is good. It just means that you can manufacture more things, and some of those things are good. So one analogy I like to use is temperature, because gravity is fundamental. Temperature is kind of fundamental. So the way I think about Varda is as if you were introducing refrigeration to the pharmaceutical industry for the first time. Cold does not necessarily make drugs better. It just means that you can now have a negative temperature slope during the manufacturing process, so you can introduce new formulations like an inhalable instead of a pill or something like that. And so it's just one extra fundamental knob that opens up that envelope, and being able to now cheaply and reliably access microgravity, or a changing of that knob, means that you can now build a business that levers the effects of that knob on industry. And we're focusing on pharmaceuticals first because the dollar per kilogram, and it helps people.
And so you have 2 customers, and that's so interesting how you figured out 2 different business models. But how do you talk to the pharma industry and tell them, hey, you've figured out manufacturing in space and it's going to help them? They're going to be like, what the fuck are you talking about?
Yeah, absolutely. So we have a little bit of a running start because the International Space Station has tested a lot of these effects that we're talking about. So Merck's highest revenue drug, Keytruda, which is a chemotherapy. It's technically immunotherapy, but same kind of thing. Jimmy Carter takes it. It's their highest revenue drug for cancer patients. And they flew that on the International Space Station and showed that on the in microgravity, if you crystallize Keytruda, you can have a uniform distribution of crystal sizes that are small enough to get through a needle for a shot. So you can change the formula from an IV bag, like a traditional chemotherapy that takes several hours in a clinic, etc., to a single shot where you can, an outpatient delivery. So it's the same drug. We don't develop drugs per se. We don't develop drugs at Varda, but we increase the number of formulations possible, like going from an IV bag to a shot. And ultimately, if you Google Keytruda, for example, that's $15,000 a gram, and that's why we're hiring at Varda.
Okay. Speaking of hiring, you mentioned that all your time almost is spent on product and then hiring, right? Like you've done thousands of interviews with engineers, and that's what makes the company. And you said some great things about the culture there. So speak more to hiring and Varda as a talent accelerator and how that works.
Sure. So yeah, I was doing the math earlier when we were talking about it, and I think I've done 1,200 interviews so far in the last 3.5, almost 4 years at Varda. And doing that many of anything, you start to pick up on some trends. And so one thing I like to say, which I truly believe, is that the fundamental source of value at every technology company is ultimately the brain power of the engineer. And so building a talent base is the first and most critical part of any tech company. And so we try to, I would say my number one job is to build the team. And in doing so, develop a common mindset, a common language, and everything kind of comes from there. And so you can kind of start to screen out and self-select the type of people that might be successful in an environment like Varda.
You said something really interesting about making people owners within the company. I'll let you say it. You said it best, right?
Yeah, so if there is a secret sauce at SpaceX, I think it's the concept of the responsible engineer, and so that is what I kind of picked that up early, about year 2 or 3 while I was there, and I was like, oh, this makes a lot of sense. And then this makes a lot of sense. And when I left and joined Bank of America Merrill Lynch, I realized that the concept of the RE is not ubiquitous throughout American corporate culture, which was baffling. I'm surprised that society exists, quite frankly, without this concept. But the concept basically is you're given a deliverable, an ultimate deliverable that you're accounted for and resourced to the hilt, except for a safety net. And so you, at the end of the day, it's a kind of an entrepreneurial mindset of, here's something that you owe the company in 6 to 12 months. Maybe it's a flight computer. Maybe it's a PowerPoint tracker for the solar arrays. Maybe it's the primary structure. Maybe it's a thermal analysis. But you own the success of that. And I leave it at that. I don't say things like, you own the design, the test, the analysis, the peer review, because every time you list something, that means that the negative space of what you're not listing is now not that person's responsibility. But you don't want that. You want it to be broad and encompassing. So at the end of the day, the thermal analysis or the primary structure or the solar arrays are successful or not, and you rise and fall with the success or failure of your deliverable. And then there's a bunch of, on day 1 of the company, if you join Varda, we have what it means to be the RE, and it's basically 20 bullet points. And a few of off the top of my head for soundbite purposes are, it may not be your fault, but it is your problem, right? There's tons of times when something happens it's not your fault. Like this past weekend, there was a electrical surge from our friends over at Southern California Edison, and we fried one of our max PowerPoint trackers on the solar arrays, and the engineer was in there on Sunday to take care of it, and it was not their fault, but it was their problem. And there's something about giving someone an ultimate deliverable with no safety net and a ton of resources that leverages that person's self-worth and identity if they are a high achiever. And it was my favorite part of working at SpaceX, was that feeling. And so I've tried to perpetuate that at Varda.
What are the other 2 bullet points?
Oh, let's see. So it might not be your fault, it is your problem. The RE is the RE is the RE. So that means that you can't have REs outside the house. So if you have, I want to go to a contractor to help me develop a schematic, it's like, all right, fine, but they're an extension of yourself. So no REs outside the house. Let's see, what else? You're the ultimate owner. Try and break up your work into clear-cut deliverables. The way I think about management of REs is managers have 3 directives at Varda. They can assign REs. That's one of the unique abilities of a manager, is you can assign, you own this deliverable, and cutting up the huge global amount of work into deliverables is a very non-trivial exercise and can lead to the success or failure of the program if done well or done poorly. They can remove roadblocks for the RE, and they can resource the RE. But those are really the only 3 lever arms that a manager has, and the rest of it is on the RE. And really capture the feeling of, if this works, it is very much because of me, kind of thing. And the last thing I'll say on that note is, I'll hear things, at the bar after a successful mission or something, and I overhear like an engineer say, man, I feel like I pushed that capsule into space with my bare hands. And I'm like, exactly. That's exactly the culture of the RE.
That's the culture we need throughout the U.S. to, bring American innovation to the forefront. Okay, that's awesome. So tell us a little bit about you recently had a big accomplishment. I don't know how much you can speak to it. You brought back a polymorph back from orbit, right? Preserved it. Can you untangle how crazy that is from a first attempt?
Sure. I love talking about this. Is my favorite story to tell.
I know. You mentioned you've seen it 100 times.
Yeah. So earlier this year, Varda became the third commercial entity ever to bring something back from orbit after SpaceX's Dragon, Boeing's Starliner, and now Varda. We named it the Winnebago capsule. And it brought back, it was successful on its first attempt. While we were in orbit, we created a drug called ritonavir, or a polymorph called ritonavir. And we patented that earlier in the year after discovering it, and then we replicated it on orbit. And what a polymorph is it's the geometric lattice structure of a solid. So, for example, carbon atoms make up both a diamond ring or graphite in your pencil. They're both just carbon atoms, but it's the arrangement that defines the macroscopic properties of hardness in that case, or transparency. And so the atomic structure, the arrangement of that crystal lattice is critical, and you can create different polymorphs of the same molecule, and that drives many of its macroscopic properties, like solubility, which is one that the pharmaceutical industry is very interested in. How quickly does this molecule dissolve in your blood depends on which polymorph you are putting into the body. So the fact that we discovered a polymorph as an aerospace company was exciting in and of itself, and then replicating it on orbit, the one we discovered was metastable, meaning it's pretty fragile. It's easy to degrade into a more stable state. And so we had to keep it under strict environmental control from manufacture on orbit down to the ground. And so one of the big questions from our pharmaceutical partners were, hey, are you really going to be able to create these fragile drug polymorphs in microgravity, have them hit the atmosphere at Mach 25, surface of the capsule gets hotter than the surface of the sun, it smacks down into the desert, and you're going to get it to the lab and it's not going to change? And so we monitored this thing, temperature, vibe, etc., through the entire reentry process all the way to the lab. And then we did an X-ray XRD, which is X-ray diffraction analysis on the polymorph to make sure that it was the polymorph as intended in the lab. And so with that data, we were able to show that indeed we could do it all the way to the ground. We showed it our pharmaceutical customers, and my favorite punchline to this story is through all the environmental monitoring, the most extreme environment that the drug saw through that whole process was the UPS truck driving through Houston. So we had great environmental control the entire time, and it's just like, here's the data, we did it kind of thing. So that was definitely the biggest achievement of the year so far, and next year we plan to do it 4 more times, January, March, June, and then again in October.
Oh my God, so 4 launches next year?
Correct.
Wow, okay. But like, let's pause there. Does everyone understand what just happened? Yeah, okay, great. Any questions? Well, this specifically I'll pause for. No, we'll do Q&A at the end. Okay. But Varda's business model specifically is very unique. It's like a pharmaceutical defense company, right? Well, tell us more about how did that happen?
So we are unique in that we're probably the only company where you can go in and see a pharmaceutical lab and an aerospace production line next to each other, like literally right beside themselves. So that part is definitely unique. Although if you look at them in a vacuum, our pharmaceutical line of business, our business model isn't unique. There's a bunch of formulation companies out there providing formulation solutions to pharma companies. We just happen to use microgravity as our niche technology for creating novel formulations. And on the defense side, the fact that we are the only reentry capsule that is flying through this regime regularly means that we're essentially a hypersonic wind tunnel. So if you think about a traditional wind tunnel where you might iterate the design of a wing, if you're the Department of Defense or anyone else designing wings, you use a wind tunnel to iterate quickly. But there is no such thing as a hypersonic wind tunnel. And so we are now that hypersonic wind tunnel. Since we're flying through that environment anyway, we have a whole new line of business just in the fact that we're doing that. So, for example, our next upcoming mission, we have some heat shield tile samples on the forebody of the spacecraft from NASA that's developing a new heat shield. We have a couple of Air Force payloads inside that are both monitoring the environment, but also getting flight heritage for the Department of Defense that they otherwise wouldn't be able to get the flight heritage at our price point. In this line of business, from a business perspective, I call it delta V arbitrage, because we're buying speed for cheap from SpaceX, reusable rockets, and we're selling it to a market that right now, if you want to do a Mach 25 test, you got to buy a $40 million sounding rocket. But we have so now the cheapest way to go Mach 25 is actually to buy a ride share, get to orbit, and do a deorbit burn, and we can do that for $4 million a payload. So we cut the price by a factor of 10. Which is great for the department, but also opens up the market because there's a bunch of things that they would have tested if the price point was there that's in a backlog that we can now access.
And I think you refer to this as technology readiness as a business, right? Oh my God, that is really interesting for those of you who are in defense. Like, I think this is remarkable. So just closing note, I think something else you're working on, which is very interesting. We talk about landing sites at length, right? And the current impact of the capsule as it lands, right, is, I think, a 60-kilometer radius you mentioned. And you're working on, I don't know how much you can speak to this, you're working on cutting it down. Like, tell us more about that and what that allows you to accomplish. What's the current challenge and then what that allows you to accomplish?
Yeah, sure thing. So we basically have, this is our tech tree. So our tech tree right now is built. First, we have a small passive reentry capsule, emphasis on the passive. So it's a ballistic reentry. And we have a satellite bus that provides service like power and comms and delta V for a deorbit burn. And then basically dive bombs the Earth and drops off the capsule, and the satellite bus burns up in the atmosphere, and the capsule survives. Now, because it's passive, essentially a cannonball with a parachute on the back, the dispersions, or where it could hit, are rather large. We have to clear out an area 60 kilometers in diameter, like you were saying. So, and that's because if the wind changes or if the atmospheric conditions change, then it could blow the parachute, for example. Where we want to go, and the next generation of the spacecraft that we're making, we'll have active controls on reentry so that we can get those dispersions down to a football field size. So in the near term, we're landing in places like Utah, or our next landing is in Australia coming up in January. And this is actually fun, just hot off the press as of this morning. We got our Australian Space Agency reentry authorization. So now we are authorized by both the FAA and Australia, and now have 2 landing sites officially that we're ready to rock and roll with.
Congratulations. Yeah.
Thank you.
Okay. I'll like to invite Jason, John, and Doug on stage now for Q&A, and I have like a question for everyone. But any closing message for everyone here?
Raise your hand if you're in the aerospace industry, or if that's like your core competency.
Oh, okay.
Okay. And what about deep tech that's not aerospace? Okay, cool. Mostly just curious.
Checks out for El Segundo.
No, I think that's pretty much it. We're a pharmaceutical company that utilizes gravity as a knob, and we're lucky enough that everything we're building also happens to be the same operation for a hypersonic test bed. And so at the end of the assembly line, our capsule either gets a defense payload installed or a pharmaceutical payload installed. And that's basically it. Pretty lemonade stand business after that.
Right. Well, Bill's hiring if any of you are looking for a job. But let John, Jason, and Doug come up. We can do that. Okay, right. Oh. Mike's worked out for you guys. Okay, so question for everyone from me, and then we'll open up Q&A. How does what each of you are building get us to Mars? Jason, we can start with you. No, we're starting with you.
No, I'm doing no mics. You missed it, but every mic doesn't work for me for some reason. So I think how do we get to Mars with Outpost? Outpost is gonna that in some way. High mass, high down mass return is super important for Mars. Personally, I'm going to create a divide here right now, but I personally don't think that we should be colonizing Mars. I think the plateau space is where we should be, and a lot easier to build there. So I'm much more interested in O'Neill. They're trying to. I'm Jinx now.
So the way I think about it is Varda's contribution to Mars is a positive feedback loop. And what I mean by that is right now every other satellite company treats their vehicles as a capital investment. So Sirius Satellite Radio, DirecTV, even Starlink, you put the constellation up, but then you make the money off the reoccurring service of its use. And so in order for us to create a perpetual demand for launch, we need to treat our spacecraft as operational expenses. And so since Varda has to come back down every time, since we're manufacturing stuff, we treat our spacecraft as an operational expense. So get a load of this. So right now, because of reusable rockets, there's a few drugs that we can make economically. Keytruda, I mentioned earlier. So by executing on those drugs, we help bring our costs down because of economies of scale and our launch providers down. So now the threshold of dollars per kilogram lowers a tad, and now we can do more drugs, which allows us to fly more drugs, which brings the threshold down, which allows us to fly more drugs, which brings the threshold down again. And so you get this positive feedback loop of the more drugs you can make means the more drugs you can make. And so what we're in that mentality, because the unit economics work, we're just going to demand a royal shit ton of launch and turn, Vandenberg into LAX. And with that type of cadence is really when transportation starts to make sense, like tourism or asteroid mining. Like the goal of Varda is that when people pitch asteroid mining companies, they don't sound crazy anymore. And they don't, because you'll have this cadence, like, of course, rockets are going up every hour, this sort of thing. There's no technological barrier anymore to rapid reusable launch, obviously. Now it's an economic problem. So if we can help solve the economic demand to go to orbit, then the free economy, the invisible hand of the market, will lift us off of this rock.
Can I borrow this? Try this. It's yours. I don't even know what the question was anymore, but it sounds awesome. It's great.
Mars.
Yeah. Well, we have to go to Mars. It'd be ridiculous not to, because it's a frontier for civilization. It means that everything there is free. Like, you want to go and have it has as much land area as Earth. You could pick up something and now that's yours, whatever that is. And it has a ridiculous amount of water ice. For anyone who hasn't just looked at it and just like been awestruck, you need to just look at Mars and go, where's their ice? And then just read a little bit about it. You'll see it's like kilometers thick. In many places, no overburden. You can land right on top of it. It's perfectly flat. That's all propellant, as long as you have power. And then you're powering the transportation of anything you can make that you want to bring there and back again. So it's kind of obvious that we must do it. Also, the really cool thing is the atmosphere is extremely low and it's lower gravity. So you want to build a space vehicle. If you have a full economy on Mars, you can build a space vehicle that's a ridiculous shape, like a donut that takes off and flies and doesn't need staging. That's so cool. Like, that's the future. Stuff we can't even think about yet. So I'm just making nuclear technology because, I ran this detailed code proving to myself that you don't do this with solar power. Not for megawatt scale fuel production, which is what a vehicle the size of Starship would need.
That's how we get to Mars now. So last question, John, you've covered also the North detail, covered all these companies in detail. How do you think all this comes together as they look at this one? You probably have this bird's eye view.
I don't know. I think that there's definitely some sort of energy here that feels like early YC era Silicon Valley, where but it's very decentralized. There's no one investor who's in all the companies, but there are a lot of people who have just quit their jobs or dropped out of school and then come here and built, and a lot of that's standing on the shoulders of giants, obviously SpaceX, and Varda was here like well before the boom and like the meme. But it certainly is valuable to have a community of builders. And I think the memes that will come out of here, not like literal memes, but like just ideas like how important it is to get to Mars. I personally think that it's also important to get to the moon as soon as possible and really start living on the moon. It's just so much easier to get there, so much easier to get back. And I think that that's something that like the actual pushes to start companies, but then also like just become like bumper stickers across all of America. We'll certainly have seeds here.
What is going to be another hub like El Segundo?
I have no idea. If you find out, let me know. But I mean, El Segundo is still growing. Like there's new companies starting up here every time, constantly. Maybe, I don't know. Do you guys have plans to expand? Or?
I'm not going to tell you if I know.
Well, with that, John, thank you. Thank you, everyone, for being here. All right, to the audience, questions? Yeah.
You guys have touched on this. So one of the common themes here is investing in kind of deep tech and developing that. For each of you, could you kind of go into a little bit of detail for when you first started, where that threshold moment of, okay, we know the technology enough now, let's go ask for money to go develop it, or in the case of Made in Space, kind of like we can bootstrap ourselves to develop it. Can you elaborate a little bit further on that?
That sounds way too thoughtful and organized. You always just go into it knowing half of what you think you know, and you have to just be committed to the mission and believe that what you're working on is the most important thing. That's it. Yeah. That's the only way.
The question is, how do you convince investors that you want to?
Well, it depends what I guess it depends what you're convincing them of. It depends what you're trying to achieve. But a lot of times you convey your vision and you convince them that of that same thing you've convinced yourself, that it's the most important thing to be worked on and that it's not too risky. And that's like, that could be like 20 questions, not too risky, or like 100. And like, it's hard to know. You have discussions with them.
I think like Will, you guys figured out a great way to do this, right? Depending on who you're talking to, it's supposed to be a different pitch.
Yeah, well, I mean, it's with the audience. If half my job these days, unfortunately, is not as much engineering as it used to be, and it's communicating, and it's no, if at the end of the day, if you want someone else to understand, it's a lot easier to explain if you understand what they already understand.
I think that might be a good takeaway. At the back. Okay, I don't know who was first.
It seems like for a lot of you, the primary customer is the government. And I've always heard, and maybe I'm wrong, that responding to those RFPs is very difficult, time-consuming, staff and labor. Is that something that you guys are doing? Are you just working as a subcontractor? How are you enabling that relationship with your primary customer or one of your primary customers?
The illusion is to lobbyists, I believe he was saying. So, he calls them different words, but like we were saying, knowing our audience. So the way I think about it is like this, right? Is at the end of the day, you're offering value in the same way you are offering. I don't actually think of it too much differently from a government customer versus a commercial customer. At the end of the day, it's still another human that you're satisfying some need, right? So it really comes down to listening to what's needed, being able to draw a thread. Now, there's definitely more hops along the way in a government partnership than with a commercial partnership, but if you can draw the thread from first principles, it's the same thing. What do you need, and how can this company provide that need to you? And then finding product market fit too, right? If you have product market fit, you feel like you're robbing the bank. And if you don't feel like you're robbing the bank, you just don't have product market fit yet, and that's okay. But that's kind of how I think about it to some extent.
Jason, you've closed like.
Okay. So, yeah, I think like my philosophy is every important aerospace company, every big important aerospace company has a foundation in government contracts and some sort of program of record, whether it's SpaceX winning commercial resupply to station or DoD programs. So that was important for us, like from day one, was go straight to that customer and just figure out how do we build something they want. And, and there's a lot of back and forth. There's a lot of understanding what it is they want when you approach them. And then working together on that vision. So what that means operationally is we have a really great government ops team that is bidding, writing proposals, constantly working with these different stakeholders, and I think like the RFP process it's scary, but honestly it's way better than it was. It's better now than it was 14 years ago when I started Made in Space. Like there's all these direct to phase 2s that you can just go get like million plus $1 to $2 million right out the gate, which is like phenomenal. Like versus like getting 100K and trying to build something with that. So I think what we're seeing with DoD contracts at least is this desire to move technology quickly, and there's real reason for that. So if you're even thinking about building a business that has government contracts, like now's the time to do it. Sure.
Do you have a lobbyist?
We do, yeah.
So,
no, not just with us. Yeah.
So the question was, do you have lobbyists? I have a follow-up question. How important is it for your government ops team to be in DC or to have a presence there? I get asked that question a lot.
100, yeah. It's like they're walking to the hill every day. So there's nothing, especially in a relationships game. Yes. That is what Gov Affairs is you got to
showing up, showing face,
to be in person. Yeah.
You have to like go do it yourself to realize how to have the respect for those people.
For those who have to do it,
because it's not that much fun, and so like you start to respect the people who want to do that every day.
Doug, would you like to add to that?
I agree with both those points. It makes total sense.
And
you need
to the original question,
and you need to go do it yourself, and at least spend significant time going.
Yeah. And so you have experience working with DOE more, right? Which is a different department. And again, the original question was government as a customer. So would you like to add to what Will and Jason said?
There's like a Milton Friedman quote on this. That's a really good one. And it's like, but it's basically, the government, the thing is they're spending someone else's money. Yeah. So they're not going to be very careful with it. And they're not really going to get a good product out the other side also. But the problem is that you can compete for that money, and everyone else is doing that. And your investors want to understand, like, why are the dollars they're giving you not turning into more dollars like they are for others? So we are forced to go and do it as entrepreneurs. Otherwise, we look like we're not savvy, not playing the game properly. And I'm more of a free market thinker. It'd be great if it wasn't the case and we could just build the tech and you could have tech compete with tech and the best product wins and everyone's using their own money so they care about what they're paying. It's not the world. So, and we got to get things done. So it's just it's another system to add.
John, would you like to add anything?
I think it's interesting that you're talking about like the just the government like buying the wrong thing, and I keep thinking about that there's some anecdote from SpaceX where I think NASA did an analysis on what it would cost to build a Falcon rocket that lands, and their estimate was $30 billion, and the total cost for SpaceX was $300 million. Something like that in R&D. And so it was like 2 orders of magnitude. And at a certain point, the question that I'm left with is like, since you guys both worked there, was it just like charity to not? Because most people would see like, oh, well, if they want $40 billion, I'll charge them 39.
No, SpaceX sued the government to force them to get him contract.
Yeah. And so there's an interesting thing about like step one is like provide a better product at a cheaper price, but then step two is like actually innovate to the point where you're delivering something orders of magnitude cheaper, which is true technological innovation, which will then compound and have residual capabilities all over the place.
Absolutely. And if you don't do that, imagine if SpaceX didn't do that, if taxpayers are buying launches, that never happens. You're spending way more money. It's bad for everybody. So you have to be in there and lobby and then succeed at the tech, make it fundamentally better. Then you save everybody money. At 40 billion spent to develop a rocket, like Starlink's probably $10,000 a month, and no one's buying it because the math just doesn't work out, and you can't build something actually new on top of like the core problem that you're working on. It's fascinating.
We had a question there. Yes.
Just curious how you view like regulatory risks or like regulatory opportunities. Particularly when you're speaking to investors, is it like an opportunity to reshape the NRC in those processes or the FAA or whoever it is that you're working with in those processes? Just curious if it's more of like a partnership or like obviously there's been incumbents that have done some of these things previously. Do you work through those systems but quicker because they've already done it, or do you reshape what's already there?
I've never heard of a regulatory opportunity. I would love to know more about that. I think I've heard about regulatory risk quite a lot. I'm not sure how to answer the question. I think nuclear is its own space, really. I mean, I talked about it very briefly, but regulating as if there's only 1,000 megawatt grid scale reactor and that's it, and it's light water based, and so it's obviously very foolish to think only in that way. But Radiant has to fuel a reactor, that first one in 50 years, and prove these are real and actually exist. And in parallel, we need to be creating regulatory opportunities, shaping regulations that make sense for our technology type. I don't know if I answered the question.
No, I mean, it's fairly broad, but just kind of curious, like how you navigate those types of discussions, and particularly with investors.
Yeah, I guess I like to think really big picture, right? My product, you can have that or you can have a diesel generator. If you pick a diesel generator that has emissions that are carcinogenic, people are just dying as a regular course of their operation. And so I know that my reactor is fundamentally better for public health and safety and is a better product because it lasts years. And so I use that to go set the bar very high and then go do the lobbying, go talk to Congress and make sure they're aware of that. And then we start slowly putting pressure on the regulator, so that as we build the real system and show these actually now exist, and we've been talking for years about them, and everyone is aware that, oh, now we can stop using diesel generators in a bunch of locations. So that's like how I'm making the regulatory opportunity exist.
So I think like something with me, right? Like my energy is like
some sort of electromagnetic field or something.
Yeah. We need to like EMI test me. It's gonna be broken in like 2 minutes. I think that they're like.
It works fine.
Did
for
it
me.
really?
Yeah, it works fine for me.
All right. It's a weird magic trick.
Yeah.
I'll give like a kind of a bit of an anecdote of where I think that there's room for like regulation to change. And this is like, I think where the opportunity lies is with new technologies is we can change regulation, but you have to do that early on with education. One of the first things I did with Outpost was, because we're learning how to make satellites that return to Earth, I kind of ran this thought experiment and crunched the numbers of, if you take every mega constellation that's like announced, that's getting built, and you just add up the number of satellites in all those mega constellations, and then make a couple assumptions, like each satellite will be in space for 5 years, and then it has to be replenished with a new one. You get to this point when they're all active, that there's a huge amount of deorbit of satellites happening, and it's like what we calculated was something like 10 metric tons per day of satellites that would get deorbited if you just kind of average it out across a year. And that's interesting because right now the regulation is your satellite after like 5 years of being deactivated has to be deorbited. But when you have 10 metric tons of aluminum and things like that atomizing in the atmosphere every day, day in and day out, what does that do to the atmosphere? And it starts to beg this question of, is burning up the satellites the right solution? And therein lies like this opportunity to go tell regulators, hey, you have to get the trash out of space because we're going to clutter orbit, but you can't let it burn up, because when we have that many satellites at scale doing it, it's detrimental to the atmosphere. And then, you know, if regulation follows that, then the companies that have already been inventing reentry technologies all of a sudden come in and like save the day when the regulation changes. So yeah, I agree. It's like a huge amount of education to lead up to regulation change.
Okay. Parting words for everyone. John, we'll start with you.
I don't know.
No, nothing. Two on the spot. Yeah, anything? You don't have to say anything. No pressure. Does anyone want to say any parting words?
I think we need a new microphone company, Deep Tech. This is the real hard.
This is the real hardware. Okay. Stop getting them from China. Yeah.
Yeah, like AI is easy, AV is hard.
That's good.
Real-time AI, right? Yeah. No? Okay. So, yeah, thanks for coming, everyone. We're all hanging out. Thank you all for joining. We're going to be here for a bit.